Alright, so this is a quick video of basically or a quick overview of what I learned throughout this course. It was the machine learning course by Stanford University by Andrew, and that's my name in the top corner. These are all my classes that I completed, all 11 weeks. And then I'll also go ahead and show some of my homeworks and my lab scripts on completion of all of them. So basically the first 4 weeks of this class were like basically a revision. As you can see, those are the topics we have: linear algebra, linear regression. Just gonna open all of them because I don't remember off the top of my head. Linear regression with multiple variables, Octave, and the MATLAB tutorials, logistics regression, regularization. This is basically neural network representation. And then in week 5 we just looked at neural network, the learning, and I think week 6 we did some advice for applying that, and then the machine learning system design. And as you can see, in all of these, complete the quizzes and then the programming assignments for these. So in the first 5-6 weeks were basically like a revision, because it basically talked about how neural networks basically work, which is the input, the hidden layers, the output, and then the output, and then the linear algebra review, the linear regression, logistics regression, regularization. And I think week 7 through the 11 is where I think we started new material, because support vector machines, I didn't know what that was. 8 was, again, unsupervised learning. I was familiar with that, but dimensionality reduction was not, so that was new. 9, we have anomaly detection, recommender systems. 10, large-scale machine learning. And then lastly was just an application example of photo OCR. So yeah, basically from week 7 to 11 is where I can really say that we learned some new material. So I will be talking about some of those things as we go along in this video. Alright, so this is my Coursera Machine Learning review, and basically I'm not going to go over the full course, because like I said in the previous video, the first 6 weeks were basically a revision of topics that we had learned in both 330 and 300 last year. So these weeks, which is week 7 to 10, were basically, to me, this is where I had all the new information per se, and so I'm going to just briefly go over all of them and then talk about some of the highlights in each week. So week 1 was basically support vector machines. I didn't know what they were prior to that, and then under the videos taught us about large machine classifiers, which have 2 cases, and then one of them is linearly separable case, and then the classify in presence of outliers. We also looked at some kernel methods and algorithms, for pattern analysis, which is basically the best known support vector machine. We also looked at some parameters, or learned about some support vector machine parameters, which is basically, when you have a small lambda in your equation, which is 1 over lambda to get your C, that basically indicates that you have a low bias or high variance. If the lambda is large, that in turn gives you a small c, which indicates higher bias or low variance. So the difference is that, so if your lambda is small, your bias is lower and then your variance is high. If your lambda is large, your bias is now high and then your variance is low. So it's basically an opposite based on your lambda, you will be able to have an idea of what your see is going to be. Also we looked at sigma squared, and we saw that it could be a way of telling how smooth a curve is. For example, like if you have a large sigma squared, that means that your features vary more smoothly, and if you have a smaller sigma squared, it means that they vary less smoothly. So those were basically the main takeaways for me from that. And then the programming assignment, those are double email processing and extraction. Week 8, we looked at unsupervised learning, and then we looked at the main difference between supervised and unsupervised learning. Supervised learning wasn't discussed, but it was talked about in unsupervised learning, which is basically, with supervised learning, there are labels, but with unsupervised learning, there are no labels. So that is a very, I would say, straightforward way of distinguishing between the two, whereby when you're dealing with unsupervised learning, there are no labels with the data, but when you're dealing with supervised learning, there are labels with the data, or labels come with the data. And then one method of unsupervised learning was clustering. And then clustering is basically a learning algorithm, an unsupervised learning algorithm whereby points are closely grouped to form clusters. So if there's a data set, and let's say we have points scattered all around, they form clusters based on how close they are to each other. And then this is good, for like market segmentation and then social network analysis. Those were some of the examples that were stated for or those were some of the good reasons where clustering can be beneficial. And then we also looked at a k-means algorithm, which basically randomly initializes cluster centroids, and then goes to a data set and then assigns each data set to each cluster centroid the point is closest to. And we then went on to look at dimensionality reduction. We looked at some motivation for this, and then it's basically, first of all, dimensionality reduction is basically, like the name says, it's just a method of reducing the number of random variables under consideration. And then some of the reasons why people do this is basically for data compression or data visualization, to have a better idea of what the data set is saying or what it's talking about. We also went and looked at principal component analysis, or for short PCAs, which was an algorithm used in dimensionality reduction. And then what this basically does is it just tries to find a lower surface or line onto which we can project data, which causes the sum of squares to be minimized. So basically, if you have a 3D, it's trying to reduce to a 2D, and then a 2D to a 1D, basically something like that. And then the programming assignment that dealt with that was the k-means clustering and PCA. Week 9 talked about anomaly detection, and that is basically just identifying anomalies. Are basically stuff that we don't perceive as basically normal, or stuff that jump out as different from what the pattern suggests. So basically, it was a way of identifying items or points that do not conform to expected patterns when you're studying data or training data. And then in this week, we went over the Gaussian distribution, because it is used in to develop anomaly detection systems. We looked at density estimation, and then we looked at ways to build an ADS. And then another topic that we looked at was recommender systems. And then, we looked at the two algorithms that could be used to build a recommender system. Collaborative filtering, which is basically one of the ways to build a recommender system, had what do we call it? I'll say it had a unique property. Yeah, it had a unique property that set it, or that made it different from the other ones. And that unique property was feature learning, which is basically, it trains itself to based on a feature, it trains itself to use other features, or which other features to use. And then a vectorization implementation using low rank matrix factorization was also one of the ways to develop recommender systems. And then finally we come to week 10, which basically talked about large scale machine learning. Again, we looked at various forms of gradient descent. We looked at stochastic gradient descent, mini batch, and then we also looked at a variation of stochastic gradient descent with convergence. And then we talked a little bit about map reduction and then data parallelism. And so now I would go ahead and show some of the programming assignments, and then how we coded in MATLAB, and also how we submitted the work, and then basically the framework of how these programming assignments were done Alright, so homework programming assignments were basically delivered as a zip file, which you had to come and download from the Coursera site. So when you click here, you basically download your zip file. It gives you your username and generation token, which is what you use to submit your assignments. Let's go back into MATLAB. So basically, I'll start with assignment 1. I'm not going to go over every assignment, but I'm going to start with assignment 1 just for the sake of, demonstration. And then when you get into assignment 1, there is a PDF file. So let me open that up again. Close this. Close that. There is a PDF file which I've already opened up here, and this PDF file is basically your guide, or it serves as your guide throughout the whole course, basically. So let's say it's your programming assignment. Assignment 1 was on linear regression, and to be honest, these programming assignments were very well commented and very well structured, because that was very, very key to helping me even understand some of the more difficult assignments, going through week 7. And so basically for assignment 1, it gives you all the files that you're expected to have, and then your exercises. So it's just a guide. The PDF is basically a guide through how you're supposed to approach the programming assignment. So if I click on EX1, which is the main script, you see here, I'm going to blow this up, I will. So what you see here is that you see your instructions, what you're supposed to do, and then under it you see the code. So as you can see, the codes are very well commented and very well structured. They're just by reading through the code, you have an idea of what you're supposed to do. Again, with not that deep a level of MATLAB understanding, because my level of MATLAB understanding is not that deep to begin with, but because of the comments and then the PDFs, I was able to just read, and then when I was in doubt, sometimes I use the internet to get let's say it was the meaning of F print F. I'll go online and check what that is, or just check in MathWorks to see what that means. So this is basically what the main code looks like. And then for the main code, for almost all of them, we never had to input anything into the main code. There were sections of the code that we needed to put stuff. So let's say, so we have compute cost, which is another script or another function that EX1 uses to run its basically analysis of its code. So if I go down here, you can see this 2.2, which is gradient descent. It gives us the update equation, and then as you read on it, will tell you, for example, it'll let it tell you, okay, so you want to minimize cost. And then for every code where you have to either put in an equation or maybe a for loop or edit some part of the code, you see something like this, which is your code here, which tells you, okay, this is where you implement your code, or this is where you write your block of code, and then it tells you what answer you should expect. So for me, this was my cost function. And then so if I go back into this, mind you, this code is already complete. So if I should go ahead and then run any of this, change the folder, go ahead and blow this up. So this is the first part of the code, like I was saying, which was basically the identity matrix. And then for every stage, it has a pause. Let me go ahead and show you that. It has a pause, and then it'll print, which is enter to continue. So you click on that, and then you continue, and then it'll run over to part 2, which is the plots are basically our data for us. Go over to part 3, gives us our cost computed. As we go down, gives us our population, and then it gives us all our necessary values. Alright, so if we go ahead and then let's blow this up real quick. Here you have all the figures, which you can compare to your PDF. Figure 2 and then figure 3 for the ones that will be in your PDF. Well, okay, so how would you be able to check your submissions and other things back in Coursera? As you see, there's 3 sections here. There's your instructions, and then there's your submission, and there's your discussion. As you can see, this is my submission for the first assignment, which is logistics regression. It shows all the parts and how the points were weighted, and then it shows your submission history, like how many submissions that you did. So as you can see, my first submission, which was basically the sigmoid function, that was the only one. So initially what I did was I did that one, and then I submitted it, tested it, it worked out, and then I did a couple. I tried to do it in bulk, and I didn't get all of them right because I guess I was missing I think I was missing my predict function, and then I went ahead and then corrected that, so it shows the time of your submission as well. And I think you need to get either a 90 or 95 to pass each assignment. Let's go for another. Let's open this up. Let's go to. Let's say if I open up yes. Which one is it? 6. Yeah, which is basically I think this was on the support vector machines, right? Open up that PDF very quickly. Just see what it was. Yes, this was a programming machine, support vector machine programming exercise. So I'm just gonna go in here because I want to show you also how we submitted the work in MATLAB for it to get read over there. So again, this is the main body. All these other scripts are codes or functions that are pulled into this to generate the necessary answers. So if I go, I'm going to go ahead and clear all of this and then run this. Sure to ask me to change the path. If not, should be able to run pretty fast. Alright, there we go. It's good. So basically that's your first figure. So this is training a linear support vector machine. Then go ahead, your visualization data. I'm just waiting for it to finish so I can go ahead and show how we submit it in MATLAB. And then again, I used the online version of MATLAB because it was easier to upload and unzip the files. I was having difficulty doing that in regular MATLAB on my computer. So it's giving us all the basically answers that we need in the workspace. So if I go ahead and hit submit, it should prompt me yes for my AD and RS systems. Okay, so if I go ahead and hit yes, because I already have a successful submission, so I'm just going to go ahead and click yes. I'm not going to generate a new token or anything of that sort. And then it shows you each section, the score that you got out of here, and then that is what then transfers over into Coursera. And that's basically how course and the codes work, all the programming assignments work in MATLAB. I mean, all in all, this course was very informative. The lectures were not rushed. Everything was well explained. There are some concepts that I will have to revisit because I did struggle with some of the programming assignments, but I was able to basically get them all to work eventually. So there are some topics that I will revisit. The good thing is that this is not, once you purchase it, there is no real expiration on it. I think you have access to the data or to the material for, I think, a very long time, so which is good. So I can go ahead and then revisit some of those challenging topics, but that's basically an overview of the entire machine learning course in Coursera.